You'll find Mirrlees Blackstone diesel engines providing power all around the world. And they've been around for a very long time. When you've made the first ever British diesel engines some 100 years ago and are still making them today, then you must have found the right formula for success. With Mirrlees Blackstone, the philosophy is simple: to be the best. Their manufacturing plant at Hazel Grove Stockport in the northwest of England is on a site of over 30 acres. It was established in 1908, a purpose-built factory which has been continually upgraded over the years. Today, it houses all the facilities vital to the success of a forward-thinking company dedicated solely to diesel engine manufacture. As well as manufacturing, there's the administration headquarters, where tenders are put out, orders received, contracts organized, plus research and testing facilities, after-sales support, and a design team inspired by a long history of concept innovation. The K and KV Major ranges were the first diesel engines to receive a British award for excellence in design and reliability. This enviable reputation of past successes has not only brought with it an immense data bank of experience to draw on, but is the benchmark for creating the concepts of the future, with the added advantage of ever-increasing computer power. When definite designs for components have been completed, they can be networked directly to the shop floor, and production is on its way. Supporting the core activity of building and testing engines are the machine shops. They constitute the largest single supplier to engine assembly. Production techniques have been rationalized into 8 discrete islands of manufacture containing related machines, each with an island team office complete with materials management, NC programmers and quality disciplines. The whole being linked by a sophisticated computer online manufacturing system to synchronize production.
Okay, the program number, Peter, is P766105.
Okay.
In recent years, Mirrlees have made a very heavy investment in automated machining centres. But simply having the right machines for the job is only part of the answer for high-quality production. You need the right people too. Personnel with both experience and training. As well as theoretical and practical training for their own workforce, regular courses are also held for customers and overseas agents.
But this is an option we prefer customers not to.
Here they can familiarise themselves with all aspects of service and maintenance. Over 80% of all production at Stockport is exported. Mirrlees diesel engines are now operating in 54 countries worldwide, and visitors from those countries are always welcome to visit the factory. Components such as cylinder heads are manufactured in Cell Z. Robots operate within this flexible machining center, FMS for short, select tooling from a library of 500 tools, as well as moving the components in and out of the system. The efficiency of complex machining centers can only be sustained if the quality of the tools they use is constantly checked to maintain accuracy. Engine frame castings weighing up to 35 metric tons require large capacity machining centres. This one is 25 metres long, stands 7 metres high, yet is capable of milling the end of this casing to an accuracy of less than half the width of a human hair. Mirrlees Blackstone comply with the requirements made by Lloyd's Register for Quality Assurance, ISO 9001, and although quality is regarded as being built in with everything they do, checks are made at every stage of production. In the metallurgical laboratory, this electron microscope enables the raw material of practically every component of an engine to be minutely examined and its chemical composition analysed. Mirrlees are in the particularly favourable position of being able to exercise very close control over their castings because they have their own foundry in Stamford. The furnaces here are amongst the most modern in Europe, capable of holding a melt of up to 28 tons and ready to pour on demand. Samples are taken from every pour to confirm the content of each individual melt. Whilst the basic engine models are the same, each will be equipped to suit its specific application and customer preferences. Typically, an engine like this, a 16-cylinder MB275 for a pump booster station in Abu Dhabi, will be assembled from 28,000 individual components. Procedure that always needs perfect planning and many highly skilled man-hours. Many small parts are stored in this automated vertical racking unit, which has computerized retrieval capabilities, saving both time and space. With assembly completed, each engine is put through its paces, with PC software ensuring full performance and data collection. After all, every engine represents a considerable capital outlay, and both Mirrlees and their customers need reassuring that an engine's power and performance match its specification precisely. And so, another PC-driven engine test begins. Not only is the performance of an engine meticulously monitored, but after testing, each engine is subjected to a routine random strip procedure to ensure that parts are performing as they should. When all post-engine test procedures are completed, the unit is removed from the test cell and transferred to be washed and painted in the new painting facility. This plant is designed to apply either traditional solvent or the now recommended water-based paints. In this installation, new technology in paint formulae and process equipment has enabled the latest generation of environmentally friendly water-based paints to be used effectively. There are several test bed areas. This one is in the Research and Development Department. The need to satisfy the marketplace with engines able to perform with more power, different fuels, greater efficiency and sustained reliability means that the R&D department will always be busy. An exciting new development in research is the ability to analyze how new component designs will perform without even making a test piece. Using Mirrlees' databank of knowledge, coupled with sophisticated computer modeling, engineers here can, for example, observe the simulation of the fluid dynamics in a cylinder head exhaust port. In the past, expensive perspex models were often used. Another program enables all the stresses, strains and deformations from physical loading to be simulated and assessed. Now, any potential areas of failure can be spotted at the design stage, well ahead of production.